Welcome back to our series video AIB analog input block. In last three session we have made a AIB block like this. Inside that block we have written the code like this. We still didn't compile or simulate that code. Today we'll simulate the code. Until today we have made the program or written the code that we will simulate. Before we simulate, we'll give the output as earlier we have shown in first session, that F1, F2, F3 like this. We'll write like this, not, or you can keep it like SS alarm or SS on like this, no problem. But as I shown first video, I'll rewrite that code as F1 will be hardware failure, that still we did not given. So F1 is our, okay, here I will write it as a boolean alarm F1, and F1 is here, you can write as the power failure, okay. And second alarm is F2, that you can write it, sorry, here I have to right here actually, okay. Here F2 mean the overflow, out of range, underflow or overflow. So here you can write the overflow or underflow. The value, input value is not in range. F3 is complementary, we will not, still we did not create that alarm, so we will not generate that output. And F4 later I will, okay, here I will write F3, but F3 program is still not created. Complementary alarm, okay. F4 means high alarms, okay, high alarm. And F5 means high warning alarm, on alarm, okay. F6 means low on alarm, okay, low on alarm. And F7 means low alarm, that trip alarm, low alarm, okay. Here you can write also another alarm, that FT calls the trip alarm, trip alarms, that is the accumulated alarm, okay. So here output written here, that F1, okay. Here I will generate the alarm, that F1 is the power failure alarm, and do power failure or wire break alarm, okay. So it will generate when wire break alarm generate, wire break alarm generate, or F1, when wire break is generate, that time F1 will be generated. So by F1 it will hold. If it is go away, but it also be holding by F1. So here and here will hold that alarm up to reset, give a reset command. So until reset command it will hold. So here I will write RST. Okay, sorry. Okay, this is the F1 wire break alarm. So one thing you notice that I have create here, I have compiled. See that F1 parameter F1 might not be initialized, F5 not initialized. Why that? This is warning alarm here. Okay, why this alarm generate? Because F1 is the output parameter. Here we have write F1 as a output. See, F1 as a output. Here you can see, if I update that block, see F1 is the output parameter, but we have used that output parameter as an input here. This is the output. Left side value is called the output, your output. Here that F1 used here as an input. So we have told you that in output parameter should not use as a input parameter. If you use for function block, it will work, no problem, but it will generate alarm. Okay, I'll write another F2, that over range, under range, low range. That low range is called the underflow, high range, over range also the overflow. So here for that 3 wire break, sorry, low range or high range or overflow over range, if that alarm came, you can write it as a overflow alarm, and it will hold here by or get F2, and when it reset, until the reset, it will not reset it by itself. It need to acknowledge by reset button, that reset button. Okay, so we have used F2 as a input, so we should not use like this. So here I will write as a another tag, that F1 internal later will generate more alarm. So here we'll write F1 internal, F2 internal. Here also we will write F1 internal, and here we write internal. Okay, so and write here that F1 copy from F1 internal. Okay, and F2 will copy from F2 internal. Okay, so here if I compile, your earlier two alarm with F1 and F2, that is minimized, that is solved. So by this way we will remove F5 and F6 alarm also. Okay, and that alarm we have generated here, that F2 internal, sorry, F5 internal, F6 internal, and here we'll write also F5 internal and that internal. Okay, and we'll copy from this variable to our output variable F5. Okay, from F5 internal, F6 F6 internal. Okay, so now if I recompile, see there is no alarm. Okay, now one thing I want to show you, that here I have write input signal as a in. Sometime that input here, if I show you here, this is also in, that in is the t-on timer in. So here we should give another variable, not the same input variable the system have. Okay, so if we write like this, that A1 analog input. Okay, so it will be like this. Okay, AIN analog input. Now we will simulate the alarm, simulate the output as well as the alarm. Okay, here for reset we will give, here the time delay is 0 millisecond. You can give by default value from here, you can write. Okay, this is 0 millisecond. Suppose you want to generate the alarm after 2 seconds when the set point, when the process value more than set point. Okay, let me check, and here I will give a 500 M500.0 memory bit as a reset variable. Okay, now if I simulate, okay, see it is 2 seconds, it came as a 2 seconds. Okay, if I go online, now value is 0 and there is no alarm, and only F6, because the output value here, see the output value is 0, but here we have set output value, if less than 500 it will show as a low alarm. F6 is low, F4 is high, low. F1 is for power failure, F1 is for power failure, F3 is complementary, and F1 is for high alarm. You can see the comments here, that high alarm, high warning alarm, and that is low warning alarm, and that is low alarm. Okay, and that is trip alarm. Okay, so if I give the value here, that suppose I don't know, suppose value came as 1000, so here it is 72, still it is not more than low value. So if I give 10,000, don't know, 10,000, so it is 7 to 3, so value should be reset. If I give the reset, okay, so it is resetted. Okay, if I reset 0, still it is okay, no alarm generated. Another thing, if you want to the value as a true during the healthy condition, suppose here you can see the wall value as a false. If you want to make it true, means 1 during the healthy condition, you have to just write here here you have to write here, just here not. Okay, just here write as a not, and here I will write that not. Okay, not. Okay, now see the F1 is true, F2 true, F5 true, F5, and other alarm F3, F4, F7 is false because we did not still generate any alarm, we did not write the code. Okay, now if I give the value it as a 20,000, so here value is 1446. So if I give the value as 25,000, okay, it is 1800. See, it is now alarm generated as a high alarm F5 because it is high, it is high alarm. Okay, if I give the value as 15,000 again, the value is output value is 1085, but it is not resetted to true, it is not resetted to false until you give a reset command to that reset button. It is not reset, now it is resetted. Again if I see, it is true. If I give it as a value 25,000 like this, okay, here see, yes, it is false. After 2 seconds we have give a alarm delay time as 2 seconds until then, and after that time 2 seconds passed, the alarm will generate if the value over that process value 1844 more than the set value here. Here we have set 1500 for high and 1800 for high. Another thing, that if you here for nominal case, it is F1 for power failure and F2 for overrange or underrange, means overflow or underflow. So if you, and nominal range is 0 to 27648. So if you give here as 28,000, that is the high range. Okay, see, high range is generated, and but here the value, our range value is, high value is 200, 2000, but here it's showing as a 2025. So if you normally the value should not come more than 27648 because that one is the nominal range. But if you get 28000 like this, means it is high range value. So in that case, if you don't want to make the value output value more than this value, in that case you can make a limit. Okay, so here I will make a limit. Just give a limit, limit, limit. Okay, limit. So in that limit function, that is the limit function, and this is our earlier code. Okay, I will make it undo. Okay, here I will write that limit function, limit here. Okay, see that limit function, this one is your minimum, this one is your max, and this one is your process value, input value. So you can make a limit that your output should not go over that high process value or should not go less low process value, but it can make the output wire break failure or high range over range that alarm should generate. Okay, so here I will give a that here I will use that function here. So limit function here. Okay, so for in is our that equation should be here. Okay, and HPV should be our max input, sorry, here. Okay, and LPV is our minimum range. Okay, now I'll delete that line because for show I have write this one, and here I'll delete this line too, this one. Okay, this comma we don't need. Okay, see that temporary out is our output function, linear function y value, and that y value will calculated from in, that is our equation, and the limit function, this is our equation, and that output will be in between that range and that range. This is low, this is high, and this is our in equation. Okay, now download again and see the okay, now see earlier it was, maybe I forgot, but it was 2014 like this maybe, but now see it is not more than 2000. Okay, now if I give the value as 27648, it will give 200, as it is high range for 27648. And see, the F2 is now true. There is no alarm. If I modify for just for 127648, or you can write as 49, just 1. See, it is not changed, but alarm is generated. Okay, if I make it 2500, see, our value is changed. No problem. So in this way you can make the output in between this range. If the input value more than or less than your nominal range, you can limit the output in between your HPB, and LPB. Okay, in next video we'll generate high low alarm